All right. So with this, everyone, on the count of three, just say hello to your missing friend. Say hello. It's recording right now, by the way.
Hey, Garrett. Hi, Garrett.
All right.
Hi, Drew.
Hello, Drew. Okay, good enough hellos. All right. So guys, we just showed before we did this, we talked about the term what's called triangle rigidity. So let's fill in the blank for that. All right. So with the triangle rigidity, we're saying if I have three sides, three line segments, and I have their lengths, if I put them together, no matter what, they come out to the exactly same shape, same size triangle. So this allows us to have different ways of proving triangles congruent than what we did in lesson 4.3, which says we had to do a lot of work. We're cutting that work back in half. What do you guys think? Not too bad, right? So what's really cool about this, let's look at the next statement. It says, it states that, because if I do this as a shortcut, it states that the side lengths of a triangle are given, the triangle can only have one shape. That means I'm going to be the same shape, same size, right? That won't change. So that's the cool thing about that. So today we're going to have two postulates that we use to prove triangles congruent. Yes, sir.
How many postulates and theorems are we going to learn in this chapter?
There's several different ones because we've had what, 4 or 5 definitions, 10 different definitions, whatever. So for this topic, there's a lot more for this chapter. On this topic alone of congruent triangles, you've got 5.
Oh, wow.
But the nice thing is the names tell you what's in the theorem. And it tells you what you need to do. So remember, we just said if I had 3 sides, I should be able to say if triangles are congruent or not if they have the same lengths. Well, look at the name of this first postulate. It is literally called the side, side, side congruence. Well, how many times did I say the word side?
3.
How many pairs of congruent sides do I need? 3. So then we just call it by side, side, side congruence. Now we're going to write this abbreviation right there. And I need you to understand your book is not going to put the congruent symbol there. They will write just SSS. Here's where I'm asking you to do it the way that I'm telling you to do it, not the way the book does, okay? The reason why we do this, later in geometry, we do a whole unit on similarity. There's such thing as a side, side, side similarity postulate. So there is, if you don't write congruency after it or the similarity symbol after it, you don't know which one you're talking about. So I want you to just get in the habit. I don't need to know if it's postulate or theorem in this. I just want you to write side, side, side congruence. Are you guys with me on that? Yeah. So let's fill this in just a little bit. Okay, with this one, says the following. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. Basically, you are physically going to have to show 3 pairs of congruent segments. Here's what I need to show you. So something like this. If you know that's the case, segment A, B, and DF, you will, in your proof, you're going to have to state somewhere segment AB is literally congruent to segment FD. That will be in a proof. All right? Then, another one you'd have to show, you could go segment AC, you would have to show would be congruent to segment FE. So now that's 2 of the pairs. Then you still physically have to show the 3rd pair, or this theorem doesn't work. So you have to show 3 pairs. You should have 3 literal congruent statements in there. So we got our last pair. Segment BC is going to be congruent to segment DE. If that's the case, then I should be able to write a congruency statement. Remember, a congruency statement is just saying 2 things are congruent between the 2 triangles. And that's what we're going to be doing for today, and that's what we're going to be doing on Mondays. We're going to be learning these congruence theorems and postulates and being able to write those. Basically, we're going to go back to proofs. We have to be able to work with proofs really well. Now, some terminology that you need to know. You need to remember what the reflexive property is. Guys, when do you have the reflexive property? All right, so Sunita just said it's when something's congruent to itself. Do you guys agree or disagree?
Agree.
It should be an agreement on this one. Remember, anytime you have the congruency reflexive property, you're going to have something like segment AB is congruent to segment AB. Remember, we even used those like that when we talked about it. So with these, this is a huge reason on a lot of proofs. Because a lot of times that's going to be your pair of sides that you need. So that's going to help us with it. So now, on this first example, and this will help you also on your homework, guys, this is something I need you to keep doing a little bit more on. Make sure you're referring to your notes when you're doing your homework. What's the other thing I'd love for you to improve on? Probably my biggest complaint about it in here is I'm not getting enough phone calls at home going, how do I do this? In fact, someone in here did this last night, and I was very excited. Guys, there's nothing on there. I don't keep you on the phone. I don't have long conversations about politics or anything like that. Okay, I'll help you. You can move on and get the rest of your homework done. But make sure I hear from you how to do it. But this is also how I want you to do it, okay? So on this one, I need to be able to explain why this works. First of all, what do you guys see in that diagram? What's given to you? What do you see? It's given what? What do you know about AB and BD? Yeah, we know that segment AB is congruent to segment DB. And what else is it given to you in this diagram? Yeah, AC is going to be congruent to DC. Now, how many pairs of congruent sides did you already just mark down? 2. Right, 2. In fact, on a diagram, I always tell people mark your congruency on one of the 2 triangles. Because if you do it on both, it gets too confusing. But that's a pair of sides, right? And isn't that a pair of sides? So I have how many pairs of sides? 2. I need a third pair. Yeah, exactly. The reflexive property. Yeah. Segment BC, isn't that a segment in both triangles? Yeah, segment BC is congruent to segment BC by what property? Yeah, by, we should say the reflexive property if I want to be a little bit better with my grammar. The reflexive property. Great. Yes?
What's the point of the reflexive property if you're just saying it's equal to itself?
You're saying that segment BC, you're acknowledging the fact that segment is used in 2 different triangles.
Oh, okay.
And so that way, that gives you the third pair. Because the moment I do that, right? Segment BC is in both. Is that my third pair of sides?
Yeah.
How many S's do I have there? 3. So why are my triangles congruent? By side, side, side. So that's what you say next. So you can sit there and say, okay, so thus, therefore, so, think of some good word. Let's try therefore. It looks a little more fun. So therefore, triangle, and then you write the congruency that you are given to you so you can end correctly. ABC is congruent to triangle DBC by the side, side, side congruence. Now, guys, think about that for a moment. What did I draw in the hypothesis part of the theorem up above? The postulate up above. Didn't I show 3 pairs of congruent segments? In my statement right here, how many pairs of congruent segments did I write down? So did I fulfill the hypothesis? Yeah, that's how it's congruent. That's not hard. Basically, didn't you just do a quick proof? Yeah, you just did a quick proof. I have a few people that will never do this without 2 columns. I'm like, oh, way to make yourself more work. But yeah, in this case, quick proof. All right, terminology. All right, this is, how we always have to do terminology right before a theorem, so that way you understand what the theorem's talking about. In this case, we're using the word included. Included in geometry means between, okay? So in this case, and I don't even love really how this is written out, but I'll get over it. It's the following. It says an included angle is an angle formed by 2 adjacent, I don't even like how that says, but I'm going to write it down anyway. Adjacent sides of a polygon. I like a term I like better is probably consecutive. Do you guys remember what consecutive means? One after the other. So if you're going around, it's the next segment going around. But really what it's saying is, right here, I have segment AB, and I also have segment BC. Do they form an angle? Yeah. That angle is angle B, correct? That angle B is included between the 2 sides. So that's when you hear the word included. That means the two segments make that angle. Does that make sense? All right. Now, let's just have some fun with this real quick. What would angle A be included between?
B and C.
No, careful. Angle A is going to be which one? BA and which one? AC. Yeah, BA and AC. Think about it. A is repeated in both, right? What would angle C be included?
Segment A, segment C.
Yeah, C is going to be included between AC and BC, right? Or CB. Exactly. They share that common vertex, right? So, terminology. Now, here's a quick question. This is a precursor to Monday's notes. Could you have an included side? The side would just be between two what? See how easy that is to catch when you realize what included just means between? It's not that bad. So look at the name of this postulate. Side, angle, side. Or it's my all-time favorite name of all postulates and theorems. Yes. Attitude that you can get away with. All right. So side, angle, side, congruence. The name, let me tell you again, tells you everything you need to know. How many pairs of congruent sides does that name tell me I have to have? 2. How many pairs of congruent angles does that name tell me I have to have? 1. Where does that angle pair have to be located? Where's the A located? In the middle of two sides. It's the included angle. So look about this, guys. Look. I have a side right here. I have an angle, and I have a what? Side. Side, angle, side. So when you're doing this on your stuff, you're literally going to have that. You're going to have to show that segment AC is going to be congruent to segment ED. You're going to sit there and say, okay, angle A is congruent to angle E. And you're going to show in your proof segment AB is going to be congruent to segment EF. I don't like how that looks. All right. But you'll have a side, 2 pairs of sides, and a pair of angles. Sometimes you don't always write it in order in your proof, but if that's what you have to have. If the angle's not between the 2 sides, it does not work. Did everyone hear me on this? It physically has to be marked between the 2 sides. So let's fill in the missing part of this postulate. It says, if 2 sides and the included angle of one triangle are congruent to 2 sides and, oh, I'm not going to make it here, the included angle of another, I'm going to do the triangle symbol here just to save us some space, of another triangle, put the R there, then the triangles are congruent. And again, the easiest way I know to recognize this is if you mark one of the triangles up by using either S for the line segment, A for the angle on one of the triangles, anything that's marked congruent, and it will literally spell to you the postulate or theorem you're going to use. Your book, if you look at the answer key, will give you numbers instead. I don't like the numbers. I like really knowing, is it side or is it the angle? It makes a lot more sense. All right, did everyone get it down? All right, so here's the thing I want you to, this is just reviewing it. It says, the letters, caution with this, the letters sine, angle, side are written in that order because the congruent angles must be between the pairs of the congruent corresponding sides. Make sense? All right, so guys, what are the 2 ways we know how to prove triangles congruent? The first way was what? Side, 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 what? Congruence. And what's the other one? Yeah. Yes, you can say SAS congruence or side angle side, and everyone will respond knowing what we're talking about. Remember, it's the only time you can get sassy in math class. All right, anyway, moving on. That was funny, come on. All right, give me something here, people, and that was not a good response on your part. Come on. All right, let's do this next one. The diagram shows part of the support structure for a tower. Use side angle side congruence to explain why triangle XYZ is congruent to triangle VWZ. Isn't this like our very first one? Yeah, so let's do it that way. Let's say, do you want to talk about the vertical angles first, or do you want to talk about the sides first? Sides, okay. So we're going to say we are given,
We're gonna have to write out like big sentences.
there's not that many. I think you're going to be okay. We are given segment XZ is congruent to segment VZ, and we got the fact that segment WZ, make sure you match them right, guys, is congruent to segment YZ. So that's what we're given first. So we have two pairs of congruent corresponding sides, correct? Now, I need, and honestly, you'd say, I either have to have another pair of corresponding sides or I have to have a pair of corresponding angles. What's going to show up? Where are they? This is only huge that you know this, people. Where I either need another pair of corresponding sides or another pair of corresponding angles to show the triangle is congruent. But they already told me it's going to be side, angle, side. So I need a pair of angles. Where are they? I have no idea what you're talking about at this point. Why do I have no idea what he's talking about?
That's the reflexive property.
There is no reflexive property in
Oh
this
my
case.
gosh.
There's no reflexive property. What?
I know.
All right, so XZY is going to be congruent to VZW because of the vertical angle theorem. There was no reflexive here. They're not sharing the same angle. Reflexive means that they're exactly the same angle. That's not exactly the same angle. There's two different locations here.
Okay.
But look at me. Did I not tell you vertical angles are going to help you all year?
Yeah.
Guess what? They're right there. If I have two intersecting lines, segments, or lines, are there vertical angles?
Yeah.
Yeah, so right here, you are going to have your vertical angles. That's the very next step. Are those angles between my two pairs of sides? Yeah, they're included angles, so great. So that's what we're going to say next. Angle XZY is congruent to angle VZW by the vertical angle theorem. The angles are included between the sides, right? If my pairs of congruent angles are between my corresponding side pairs, are the triangles congruent? Think about what if I labeled it when we do this earlier. I have my side, I've got my pair of angles, and I got my side. Do I have SAS? Yes, so then we know they're congruent. So say that then. So therefore, triangle XYZ is congruent to triangle VWZ by the side angle side congruence postulate. If you just said side angle side congruence, you don't have to use the word postulate. I'm good with that. But yes, basically, are you explaining what you would do in a proof?
Yeah.
But that's what explaining is. It's justifying what you're doing. Guess what we get to do, the very next thing?
Approve.
Approve. All right, you've got to be able to start proofs and use what you need to do. Guys, we haven't done proofs for a few days, really, without any help from the teacher. So you need to take the time and review all the way from chapter 1 through chapter 3. Why? Because if you don't, you're not going to know the reasons. And you're expected to know them for this. Like, for instance, you guys really didn't respond fast enough for the vertical angle theorem. You should have recognized that really quickly. There can't be a hesitation on stuff like that because you're supposed to have known it, I think since what, chapter 2? I think maybe the beginning or the end of chapter 1. It's been a while. You really do need to know it. So with any proof, just like these before, guys, don't write real big with this because this is going to be a 7-step proof. All right, make sure we have our 2 columns. The nice thing is you don't have to write out those long sentences. We can just write it down in our steps.
I am getting picked on.
Yes, yes, you are. Okay, anyway. But we need to still mark up our diagrams, and we need to logically be able to put this stuff down. Now, guys, like all proofs, where do we start?
Given.
With our given. So let's start with the given here. So, and really, could you start with either one?
Yeah.
Yeah, it's okay, either one that you do. So on this one, I'm going to go segment PN bisects segment MO.
Given.
All right, guys, what do you know? If I have a segment that bisects another one, what should you get as a result? Yeah, very good. Two congruent segments, very good. All right, what two segments are going to be the ones congruent? Right on, so let's write them down. So segment MN is going to be congruent to segment NO, and that's definition of a segment bisector, right? A segment bisector gives you two congruent segments. All right, awesome. Okay, so I've used that given. Now what I'm going to do?
Go back to given.
Yeah, go back to the given again. All right, so on this one, I'm going to have segment PN is perpendicular to segment MO. When you have perpendicular lines or perpendicular segments, what type of angles are formed? Right angles. That's what you're going to end up using here. Because remember, I want to show pairs of congruent angles. So I know these two angles, would you agree with me, are right angles? Yeah. All right, that's what you're going to put next then. You're going to tell me that angle PNM and angle PNO are right angles. How do I know that? Because I have perpendicular what? Yeah, I have perpendicular lines. So that's just the definition of perpendicular lines. You could say line segments if you want to be more exact with the diagram. Because if I have perpendicular ones, we know they intersect at right angles. Guys, what do you know about all right angles? All right, give me another one. Go back to the theorem now. They're all what? I love the fact they're all 90 degrees. That's wonderful, but I don't want to do more work in my proof. If I wrote that down, I'd have to do a lot more work. Remember, I'm trying to show that angles are what? Congruent. So if I can skip to get there, I'm going to. Well, don't we have a theorem that says all right angles are congruent? This is where we're going to use it, and you're going to use that a lot this chapter. So my very next step is going to be angle PNM is congruent to angle PNO because all right angles are congruent. Now guys, look what I have marked in my diagram. I have a pair of sides. Let's switch this real quick. Do I have a pair of angles? All right, I need another pair of what? Yeah, if I'm going to keep doing this, I need another pair of sides. I have no more givens, at least not in the given statements. I now have to go back to my diagram. Do I have anything else that's congruent? You said P, which one? Yeah, segment PN. That is the reflexive property. Yes, yes. That is the reflexive property. Exactly. So on this one, I get segment PN is congruent to segment PN by the reflexive property. Do I put the lessons that we just learned on the quiz? Nope. 4-1 through 4-3 though. Okay, not 4-4. All right, so with this one, guys, what does it spell on that triangle? I have side. So we know the triangles are congruent. Like if it spells either side, side, side congruence or side angle, side, remember the angle has to be right there between those two line segments or it does not work. So we're done then. So therefore, and by the way, that's just a therefore symbol. Therefore, triangle MNP is congruent to triangle ONP by the side angle side congruence. A little bit of sass with that. Now, that's really not that impossible of a proof. Now, I guess I'm helping you on this a little bit, and I think the proofs that you have in your homework, I think you fill in the either missing statement or the missing reason, so they're not going to be that bad. But guys, we do expect you to be able to do a simple one of these. All right, so let's keep working on this one. This one you're going to want to know how to do because this will also help you on some homework problems. Are you guys with me on this? Yes. All right, the number one thing you guys need to improve upon besides actually grading your homework like I asked you to is to actually show your work that goes with it. Because when you don't, I don't give credit. That's why a lot of people get 7s or 8s on their homeworks is because there was no work matching the answer. So you have to make it actually kind of go together or I don't believe you, okay? Especially since we give you the answer keys. So on this, they're asking us to show that the triangles are congruent for the given value of the variable. That means I need to truly show that I plugged it in to get the segment lengths. So this is what I'd like for you to do, something like this. If x is equal to 5, do you guys agree with me that segment QR is equal to 5? Is that right? So if it's equal to 5, what do you know? Segment QR is going to end up being congruent to what segment? Right on. All right, did I just show a pair of congruent sides? So I really have one S down, is really what I've just done. Now, pick another side that you want to do this with. So do it with RP, that one? All right, so let's do it with segment RP. All right, so that means I'm going to go 3 times 5 minus 9. Well, what's 3 times 5, guys? Minus 9 equals? 15 minus 9. Well, okay, 6, right? So what do we know about segment RP and segment OM? They're congruent because aren't they the same length? Didn't we just show that's true? And we showed that earlier that those two, oops, excuse me, wrong one marked there, that those two are true. So basically I have how many pairs of sides so far? 2. Let's finish with our last pair because you have to show that's the case. So I'm going to sit there and go with QP. That's going to be 5 plus 2, which equals 7. So if that's the case, don't we know this is true right there? So we know segment QP is congruent to segment NM. Guys, do I have 3 pairs of corresponding sides congruent? So do we have S, S, S congruence? Yeah, okay. So that's what you tell me then. By side, side, side congruence, triangle, and just name the triangle M and O. Since they already did it, we can easily use the directions here to do it. Is congruent to triangle PQR. Could I also say like, therefore, triangle MNO is congruent to triangle PQR by the side, side, side congruence? Yes, that's the same type of scenario. All right, basically, did we almost do like a numbers proof? Like I just proved it by just putting the numbers in. Great. All right, this one's kind of fun. It says tell or write which of the side, side, side congruence or the side angle side congruence postulates, if either, can be used to prove the triangle's congruent. If no triangles can be proved congruent, write neither or neither, however you want to say that. Here's the thing. This is how you're going to see it written in your book. Remember, you were always going to think what? And always write it with a congruent symbol though, okay? So look with me on that first example right there. Let's mark what we do know. Guys, do I know a pair of sides? And what else do I know? New pair angle. Is there anything else in the diagram that I have? In between, okay? Now here's my question. Does it give me side, side, side or side angle side? Really, this gives me what? Side, side, oops, make sure I wrote my thing here. Doesn't that really give me side, side angle? Be careful not to write it the other way. Right? We're a good Christian school. We only write it this way. All right, anyway,
Wait a minute.
here's the thing.
Why isn't it SAS?
Why isn't it side angle side? The angle has to be where? Between the two. So basically, this is going to be what? Is it, but is it SSS? It can't be SSS because do I know the third pair of sides? So this one's what?
Neither.
Yeah. Or neither if you're, with that type of cool accent, all right? Or neither. Because here's the thing. That's cool. You have a cool accent. Natanya goes, it's neither. Okay, perfect. All right. Here's the thing, though. It didn't work because the angle location was wrong. In order to be SAS, the angle physically would have really needed to be right there, correct? They would have changed location. Excellent. Guys, talk to me about number 2 over there to the right. Do I have side angle Side. This is the only time you can yell sass out loud and you don't get in trouble. That's exactly. So it's side angle, side congruence. You don't get that like, are you sassing me? No, you got to actually get away with it, so it's good. All right, so side angle, side congruence. Excellent. How about number 3? If you marked it, you get side, side what?
SSA.
Does it work?
No.
No, for it's neither. For Natando's sake, we're going to honor Natando today. Okay, so it's neither. Awesome. Number 4.
SSS.
Yeah, because if you marked it right, if we matched it up correctly, you got a pair of corresponding sides here that are congruent. The 4s are congruent. The 6s are there. Right. This was side, side, what? Yep, side, side, side. Congruent. Excellent. What do you guys think? Make sense? Okay.
If that's going to go on, then I'll hold it.
Well, basically, you're going to have to do some proofs. It's basically what you've seen here. Try this one. All right. This is kind of like when we did with parallel lines. Because remember, sometimes we're like, okay, the lines aren't parallel, but we want them to be parallel, so solve for the variable to make them parallel. So in our brains, we assume they were what? Parallel. Okay, this is that moment. I know, isn't that crazy? It's like, this is the same thing. Like, right now, can I prove right now that those triangles are congruent?
No.
No. I have 2 pairs of corresponding sides. I want the 3rd pair. So look what the question's asking. It says, find the value of x so that the triangles are congruent. So what do I get to assume about those 2 pairs?
Set them equal.
Yeah, I'm going to set them equal to each other to make them congruent. So you're going to get here 20x is equal to 22x minus 3.6. All right, what are we going to subtract from both sides, guys? 22x. All right, so let's go ahead and subtract 22x from both sides. Please be careful with your algebra on this. Again, negative 2x is equal to, and this is what happens, a lot of people drop the negative when they shouldn't be, a negative 3.6. What am I going to divide both sides by?
Negative 2.
Awesome. Negative 2, negative 2. X equals? It's 1.8. 1 point something was pretty close. 1.8 to be exact, though. Now, why is that okay to do a decimal there? Because did it start with a decimal?
Yeah.
If there wasn't a decimal there to start with, what do I want from you guys?
A fraction.
All right, I think we finally got there. That's great. Okay, looking at B over there. All right, with this, guys, do I have a pair of sides and another pair of sides? What's being marked, right? I want it to be side angle side. It's not there. I want that way. So what do I assume about my 2 angles? Excellent. So let's do it. So I get 6x minus 27 is equal to 4x plus 7.
On our notes, we can't see the minus or plus.
That's okay. So put it in.
Okay.
That's a simple thing to solve. So the copy machine need to copy it well. Solve it. I mean, to me, that's not a life issue here. Just put it down. All right. So let's keep going. What do I do next? Anna, what do I do? All right, so you were going to add the 27. All right, so we're going to add the 27 both sides. So I get 6x is equal to 4x plus, what does that give me? 34.
Minus the 4.
Yep, minus the 4x, not just the 4, right?
Yeah.
The 4x. All right, guys, so I get 2x is equal to 34.
17. X equals 17.
Yeah, what do you guys think?
Yeah.
Not too bad, is it? Don't be surprised if you see a problem that looks a little bit like this, though. Are you guys ready?
I like this better than
Okay.
that.
All right. What if you had a problem and you were solving like the one of the last two, and you maybe got something like this? 3x squared is equal to, let's say, 150. You can just watch. I'm okay if you just watched. How would I solve that? All right, so I divide by 3. Okay. I agree with you guys on that. So I get x squared is equal to 50. Then what? I got to do what? Square root it? Okay, careful though. If you square root it, what do you have to put in front of the radical sign? when you are solving an equation. Like if there's a square root symbol already in place, no, you don't do that. But in this case, I'm solving for it, so I have plus or minus. Now guys, we've been practicing this just a little bit, right? All right, so when we do that, we get our two values. You get 25 and you get what? 2? What's the square root of 25? So my answer, plus or minus 5 root 2. Stuff like that's going to show up in the homeworks. That's why I'm showing you. That's the reason why we were reviewing it earlier after the test the other day. This is not, like I said, this is just to remind you of some algebra skills. But guys, you all know this stuff, okay? You all know this stuff. All right, homework is very much similar like this. So what I want you guys to do now is to now pull out your practice quiz. All right, and we are done.